Lights can be bright, dim, and everything in between. Sometimes how bright something appears depends on how far away it is from us. When we see two identical cars next to each other, we can see their headlights have the same brightness. Their absolute or intrinsic brightness is the same. But when one pulls ahead of the other, we see its headlights appear brighter than the car left behind. The apparent brightness has changed. The same thing happens when we look up at the stars. In astronomy, we talk about the brightness of objects using magnitude. On the magnitude scale, bright objects have a low magnitude and dim objects have a high magnitude. How bright a star looks from our view on Earth is called apparent magnitude. If we look up and see one really bright star and one dim star, then we would say the bright star has a smaller apparent magnitude. However, this is only how it looks from Earth. It could be that the star only looks bright to us because it's closer to us than the other stars. If we lined the stars up at the exact same distance from us, we could compare their intrinsic brightness. We call the brightness a star would have at a distance of 10 parsecs from us the absolute magnitude. So, if we know the absolute magnitude and we can measure the apparent magnitude of an object, then we can use these to work out the object's distance from us in space. Some types of astronomical objects and phenomena have a known maximum brightness or absolute magnitude. For example, when a certain type of star explodes at the end of its life, called a Type 1a supernova, the maximum brightness of the explosion is fixed. When these explosive cosmic events occur in distant galaxies, we can compare their absolute and apparent magnitudes. Then we use this to calculate an accurate distance to the galaxy and build up a map of our place in the universe.